So I want to use the applet over on the friction tab here, same applet as before, to demonstrate friction. So what I'm going to do is I'm going to have the man apply a known force to this 50 kilogram mass. And in this case, we will have friction. So you can change the amount of friction by changing this. I'm just going to change this, leave this alone, maybe change it later. We'll see how the time goes here. Okay, so let's set a certain amount of force here. And so now as I increase the force, it's now at 43 newtons. The net force is 0, and you can see that the frictional force is pointing to the left, and it's balancing the applied force of 43 newtons, which the man is applying to the right. If you increase this a little bit more to, let's say, 60 newtons, the applied force is now 60 newtons to the right. The frictional force continues to increase. This is how static friction works. Static meaning there's no relative motion between the 50 kilogram mass and the floor. And so we can increase this. We can keep on increasing it. But when we get to a force of 125 newtons, that's the threshold force beyond which we start getting a net force here. So in other words, the frictional force, static frictional force, can increase up to a maximum of 125 newtons. And beyond that, an increase in the applied force will cause an acceleration. And so let's, for example, let's give this a 150 newtons, like that. So I have a 150 newton force to the right and 125 newton force to the left. The latter one being the frictional force and the former one being the applied force. And so the way we would draw this as a free body diagram would be like this. Okay, so here's the 50 gram mass. And the 50 gram mass, let's draw all the forces on there. There will be a downward force of the weight, which is m times g. And there will be an equal and opposite upward force of the normal force of the floor on the 50 kilogram mass. And there will be a F applied in this direction, and then let me change this one slightly, just change the prefix. Force of the man on the mass m, and then a slightly shorter vector backwards, which represents the static friction. And so these two forces are equal and opposite, the n and the mg. There's no acceleration in the y direction. And so here are the axes for this problem. That's the y-axis, and this is the x-axis. And so if we did a Newton number 2 in the y direction, what we would get n minus mg is equal to m times a sub y, but a sub y is 0, and so n minus mg is equal to 0. In other words, n is equal to mg. And a Newton number 2 in the x direction would give F of big M on little m minus F sub f is equal to m times a sub x. And so therefore a sub x is F of big M on little m minus F sub F over little m. So for our problem, that would be 150 newtons. Notice the bookkeeping of plus for the applied force minus 125 newtons over 50 kilograms is 25 newtons over 50 kilograms, which is 1/2 a meter per second per second. Okay. So if I activate this, let's see if the speed scale is the same as what we set it to before. So in 10 seconds, the velocity should be 5 meters per second. If we have this acceleration, I'll just let you do some math in your head there. So let me do a count to 10 after I push on this. 1001, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1009, 1010. Yeah, it looks like the calibration is the same as it was before. Okay, now what happens if I push with less force? If I push with less force, so if I just reset everything here and go ahead and tick all of these so that we get all the values and everything. And let's say that I put the 50 grams there for the guy to push, and I give 100 newtons. What's going to happen if I start the push here? Predict what's going to happen when I start. Okay, I'll give you a second to think about it. Okay, I'm going to go ahead and start. And you can see that there is no change in velocity. The 50 kilogram mass is initially at 0. The acceleration is 0 because the net force is 0. That's what this is showing. The sum of these two gives the net force, and they are 0. Plus 100 minus 100 is 0 newtons, and therefore the acceleration is 0. Okay, so we'll be talking much more about friction, but this is a good simple one here.